Okay, equations with grouping symbols. So exercise 6C from the text. I think you're going to find this exercise quite straightforward. So there's only a few examples to go through and then you can get cracking on the work. All right, the first one we've got, it says solve, which is basically you need to find the value of the pronumeral. And we're going to do the first one. It lends itself to two different adventures. So the first way we're going to do it is if we expand the brackets. So if we expand the brackets on the left side, we have 2 times x, which is 2x. 2 times negative 4 is minus 8. And then we've got our equals 16. Okay, the negative 8 is the furthest thing away from the x in terms of order of operations. So it's the first thing we get rid of. Adding 8 to both sides, we've got 2x. And on the right-hand side, 16 plus 8 is 24. Now we've just got to get rid of the hanger-on of the 2 times x. The inverse operation is to divide both sides by 2. And we end up with, therefore, x is equal to 12. There's a second way we could do this, and it again correlates to the order of operations. If we had have known the value of x, in terms of calculating the left side, we'd do the brackets first, and then we times by 2. So when we're unwrapping to get to the x, we do it in the opposite order. The last thing we do in the order of operations for a calculation is the first thing we would undo in solving the equation. Okay, and we can divide by that multiplier of 2. And those 2's cancel nicely, and we're left on the left-hand side with x minus 4. And on the right-hand side, it's nice to divide by 2 because 16 is an even number. So 16 divided by 2, we get a whole number answer of 8. To get the x, we just need to get rid of this minus 4. So we add 4 to both sides, and we've got, therefore, x is equal to 12. So we got the same answer, x equals 12, two different adventures, both equally valid, probably even both equally difficult, okay, or easy, whichever, glass half full, whichever way you want to look at it. But you just need to do whichever one you see first and you think is going to make the less opportunity for errors, okay? This next example looks very similar, but it doesn't really lend itself to the second way so much. Okay, so we're going to go for expanding the brackets, but let's just think about if we had have done the second way of dividing by the multiplier, dividing both sides by the multiplier, it works out fine on the left-hand side, but on the right-hand side we get 7 divided by negative 4. So negative 7 on 4, we're in fraction land, which just makes things a bit more difficult and a bit more opportunity for error. So it's definitely safer for this particular one to just stick with expanding the brackets. Okay, so we've got negative 4 times x, so negative 4x. Negative 4 times negative 3, negative times negative is a positive. 4 times 3 is 12. And we have equal to 7. All right, we need to get rid of that plus 12, so subtract 12 from both sides. So we end up with just the negative 4x on the left-hand side. Oops, sorry about that. Negative 4x. And on the right-hand side, 7 minus 12 is negative 5. Need to get the x by itself, so that times negative 4, the opposite operation is to divide both sides by negative 4. And we end up with, therefore, x is equal to negative 5 divided by negative 4. A negative divided by a negative is a positive, and the number is 5 on 4. And you can just leave your answer as an improper fraction like that. Unless you're specifically asked to go for mixed numerals, it's totally fine to leave it as an improper fraction. Okay, this next one's a bit more complicated. It's got a bit more going on. As well as that multiply, it's got a extra plus 1 hanging on. So we'll actually go, first of all, to expanding the brackets technique. So we've got 3 times x is 3x, plus 3 times 2 is 6, plus 1 is equal to 19. Cleaning up the left side, we've got, so 3x plus 7 is equal to 19. Taking the 7 from both sides, we've got 3x is equal to 12. And then dividing both sides by the 3, we've got, therefore, x is equal to 4. Okay, so just expanding it out, collecting your like terms, and then working your way to getting the pronumeral by itself. We can actually do this one slightly different adventure, but equally valid. If we think about on the left-hand side our order of operations, if we knew the value of x, we'd go x plus 2, we'd do that calculation first, then we'd multiply by 3, and then we would add 1. So if we're trying to unwrap back to the x, The last thing we did in our calculation is the first thing we would take off when we're trying to solve the equation, which means we would take that 1 off from both sides, which would leave us with 3 brackets x plus 2, and 19 minus 1 is 18. Okay, next thing to unwrap is the 3, and it's fine to unwrap the 3 by dividing by 3, because 18 divided by 3 is a whole number. So we've got on the left side those 3, oopsies, those 3's cancel out, so cancel. We've got x plus 2 equals 18 divided by 3 is 6. Now we just need to take 2 off both sides, so therefore x is equal to 6 minus 2 is 4, which looks pretty promising because it is exactly what we got using the other method. Okay, both of those methods are totally valid. You just do whichever one you think suits you best, and whichever one's going to make you make the least errors. Okay, last example for this exercise, and this time there's heaps of action. There's 2 brackets. We don't actually have a choice. The only way forward safely is to expand the left hand side, collect some like terms and solve. So let's go for it. Expanding it out, we've got 2x, oh, in green, that's spicy. Let's go for blue, hang on, get rid of that. Pause it. Okay, let's go for blue. 2x minus 14 plus 3x, it doesn't want to behave for me, plus 3x plus 6 is equal to 47. Okay, let's collect our like terms. 2x plus 3x gets us 5x, and minus 14 plus 6 is minus, I think my computer's tired. Minus 14 plus 6 is minus 8 is equal to, oh come on, please work. What am I up to now? I've lost track. I think it's just still at 47. Okay, and then we've got to add 8 to both sides, so we've got 5x equals 47 plus 8 is 55. And then we divide both sides by the 5, and therefore x is equal to 55 on 5, which is 11. Okay, that was a bit complicated, so I'm not super confident we got it right. So let's do a check. So remember, our way to do the check is to do the left-hand side first. So left-hand side equals, so we can plug the 11 in, and hopefully when we calculate it out, we'll get 47. So we've got 2x minus 7, so 11 minus 7 plus 3 lots of 11 plus 2. Okay, so we've got 2 times, so 11 minus 7 is 4, plus 3 times 13. Oh, come on, 3. Let me just make that a bit nicer. Okay, so 2 times 4 is 8, 3 times 13 is 39, 8 plus 39 is 47, which is good news because that is equal to our right hand side, and so we can be confident that we have got the right solution. Okay, so basically in this exercise, the way that will always work is to expand the brackets and then work your way through the equations like you normally have. But sometimes there's a little quick shortcut. If the numbers and factors work out well, sometimes you can do a division, but you have to make sure you're doing the same thing to all the terms on both the sides. All right, so that's exercise 6C. We're also going to do exercise 6D a bit today as well, but get a bit of practice on this before you watch the next exciting episode, and check Schoology for the questions, and I'll see you back here for exercise 6D in a little bit.